In this problem, you need to identify the value of each symbol. So we need to find the number that is replaced by each of these animals. Now you can either take the trial and improvement method, or you can use the clues that are on the screen and work in a more systematic way. I'm going to show you the trial and improvement method first, and I'm going to demonstrate to you a way that you can even do this with younger children. Let's look at how we can use counters to solve this algebraic problem. So we know that our top row equals 23, so I've got 23 counters here. Now you can use tally marking, you can use Lego pieces, you can use anything that you've got that your child might be able to hold. So I know that my top row adds to 23, and what I want to do is separate that 23 into two groups, because I've got whales and I've got a leopard. So for example, if I decided to make my leopard worth 5, I would swap 5 of those counters for the leopards, or I might just separate them or swap them for a different colour if you have that. So I've now put 5 counters, assigned those to my leopard, and then with my whales, I know that the remaining 18 I need to split equally into 2 groups. So I now have my first guess that my whale is 8 and my leopard is 11. Okay, now what we could do is we can test that out using the bottom row, because in our bottom row it also just has leopards and whales. So if my leopard is worth 5, I'm going to represent the bottom row using my counters. So I've now arranged my counters to make the bottom row, because we earlier said that the leopard was worth 5 and that the whale was worth 9. Now if we count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. The bottom row only adds to 19. So we know that the answer is not correct. So we need to go back to the drawing board. We need to go back to the beginning and see how we can arrange those initial 23 counters into a different amount. So perhaps we want to make each whale have more than 9, or maybe you want to have each whale worth less than 9. So here I've arranged my 23 counters into different amounts. This time I've made each whale worth 6, and I've made the leopard worth 11. So if we were to take those numbers for each animal, let's test it out with the bottom picture. So let's test this out. This time the leopard is worth 11. So let's count 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Let's count the whale now. 23, 24, 25, 26, 27, 28. We can see that we've got too many. So we need to go back to the drawing board. So each time, take your counters and change the value of each animal, and then just keep testing it out. If you think the whale is worth 7, for example, then represent each whale with your 7 counters, and then see what you need to make to total 23. And then test it out with the other rows. I'm using MathSpot, which is free to use, and if you go on to MathSpot, you'll see at the top there is a menu which has manipulatives in the menu bar. If you click on manipulatives, you have a load of different resources you can use. I have used counters on the left here for my demonstration today. So if you click on that, it will take you to counters that you can move. If you've got touch screen, you can obviously touch your screen using it, use a pen to move them around, or your finger. But you can also use your cursor if you don't have touch screen. So you can do the same thing without manipulatives. So you could simply give your whale a figure. So for example, I might say that my whale is worth 5. That means I know this whale is worth 5, and altogether these are worth 10. If I know I need to add it to something to make 23, I simply do 23 take away 10, which is 13. That means that my leopard must be worth 13. I can then label my other leopards as 13. If I come to the second row, if my leopard is worth 13, I'm going to subtract that from my total of 25 to give me 12. I know both monkeys must add to 12, which means each monkey is worth 6. If I now come down to my bottom row, I've got up the top here that my whale is worth 5, and I can check 13 plus 13 plus 5 actually adds to 31. So I know that the numbers I have are incorrect. So what I would now do is I would change my numbers. I need to decide whether I want to make my whale larger or whether I want to make my whale smaller. But then you would give it a go. So for example, let's go 6 and 6, which is equal to 12. That would mean that my leopard was 11. If my leopard was 11, and I took 11 from 25, it would mean my monkeys would be 14, which means each of them would be worth 7. I've got that my whale is worth 6. 11 plus 11 plus 6 is 28. It's still not the right answer, but it is going in the right direction because previously we had 31, now we've got 28. So I would keep increasing the size of my whale because I was on 5 before. I've changed it to 6 and I'm getting closer to the answer. So you would go back and give them another value to test out. Let's look at a way to do it being a bit more systematic. Okay, using the information on my screen, I can find out some facts. For example, if I compare the top 2 rows, I can see that the only differences in the top 2 rows are that the 2 whales have been replaced with 2 monkeys. So if I look at the totals, I can see my second row is 2 bigger. That tells me, as my leopards are the same, that my 2 monkeys add up to 2 more than my whales. I know then that each monkey is worth 1 more than the whale. Okay, that is quite important information going forward. Now, if I then look at my first and my third section, my third row, the difference is that 1 whale has been swapped with 1 leopard. So I've got a leopard and a leopard, a whale and a whale, and then I've got a whale and a leopard. So these have been swapped and my total is 2 more than my first total. So that must mean that my leopard is worth 2 more than the whale. So the information I now have is that the whale is the smallest, the monkey is the second biggest, and that the leopard is the biggest. So I now have an order for the symbols, for the animals. And the order is whale plus 1 equals the monkey plus 1 equals the leopard. So that's going to help me with calculating my answers. So for example, as before, I thought about the whale being 5. Well, using my formula, I know that the leopard has to be 2 more. So the leopard would have to be 7. But that doesn't work because 5 and 5 and 7 is 17. So if I adjusted it, 6 and 6, my leopard would have to be 8. 6 and 6 is 12 plus 8 is 20. So that doesn't work. So if my whale was 7, my leopard has to be 9. 7 and 7 is 14 plus 9 is 23. That works. Okay. So using that that first row of values that we found, and using my formula, my monkey is worth 1 more than my whale. So my monkey must be worth 8. 8 plus 8 is 16, plus 9 equals 25. That one works. And then popping it down the bottom, if my leopard was 9, and another 9, and a 7, 9 plus 9 is 18, plus 7 is 25. And there we have it. It works. So sometimes comparing the values, looking at what you can deduce from the pictures, will lead you on a bit of a trail of breadcrumbs to find more and more clues. For this example, I'm going to again show you some different ways to solve the problem. So this time I have some clues about each of my animals. I know that all of my animals add up to 20, so I have 20 counters. Again, you can use Lego or any object or tallying. So I'm going to start with my kangaroo. It says that my kangaroo is greater than 11. That means it can't be 11, it has to be greater than. So for example, it could be 12. So I'm going to arrange 12 counters. So that's 12. Next, it says that my owl or my bird has to be less than 4. So for example, it could be 3. And next it says that my hedgehog is greater than 4. And I have 5 left. So that is one possibility. So you would write down that the kangaroo was 12, that the bird was 3, and that the hedgehog was 4. Now, are there other possibilities? So, for example, if my kangaroo was 12, my bird could be 2, and my hedgehog 5. 6. It still works. And what about if I changed my bird to 1 and my hedgehog became 7? It still works. Everything still matches. So what about if my kangaroo was greater than 11? If it was 13, my bird could be 1 and my hedgehog 6. I could have 13, 2 and 5. But I can't have 13 and 3 because now my hedgehog, it doesn't meet the right symbol. Now my hedgehog is not greater than 4. So what about if my kangaroo was 14? My bird could not be 2 because my hedgehog is only 4. But my bird could be 1 and my hedgehog 5, so that would work. Are there any other solutions? So here we would work through each of the animals one by one and looking at the criteria. So we know that our kangaroo has to be more than 11. So the absolute smallest it could be is 12. Now, if my kangaroo was worth 12 and I need to make 20, I know my bird and my hedgehog have got to equal 8. So I'm going to go to my bird next, and the smallest my bird can be is 3. Which means my hedgehog has got to be worth 5. Does that work? Is it greater than 5? Yes, it is. So one possibility is 12, 3. So one possibility is 12, 3, 5. Now, could I keep my kangaroo as 12 and change my bird to 2? What would that make my hedgehog? It would make my hedgehog 6, and it does still meet the criteria. So I could have 12, 2, and 6. Could I keep my kangaroo at 12 and change my bird to 1? 12 and 1 is 13, so my hedgehog would have to be 7, and that works. So I could have 12, 1, and 7. Now I don't want to have a 0, I need a whole number. So we've done all the possibilities where the kangaroo is 12. So let's have a go at if the kangaroo was larger than 12. And again, let's go to the smallest or the greatest number the bird can be, which is 3. If my kangaroo was 13 and my bird was 3, my hedgehog would have to be worth 4. And that does not work because even though 13 and 3 and 4 is 20, 4 is not bigger than 4. So that does not work. So what about if we made my bird worth 2? The hedgehog would now be worth 5. And that would work. That is a possibility. Now you may be looking down at the list and seeing a way that you could just use this list rather than writing it up the top here. Okay, if you've spotted a systematic way to do it, then go ahead and use that. So I'm now going to make my bird even smaller. If my bird was worth 1, then my hedgehog would be worth 6, and that does work. Now you might be thinking this will go on forever and ever, but it doesn't. It does stop. When you see a question where it says list all the possibilities, it means there is an ending. Now, my bird was 1 a moment ago. I can't make it less than 1 because that would be 0. But what I can do is make my kangaroo bigger. So if my kangaroo was 14 and I made my bird 3, which is the biggest it could be, my hedgehog would be 3. And that is not bigger than 4. So if I made my bird 2, my hedgehog would have to be 4. And again, that doesn't work because it is not bigger than 4. So if I made my bird 1, my hedgehog would be 5. And that does work. So those are all my possibilities for 14. What about if I made my kangaroo 15? If I made my bird 3, my hedgehog would have to be 2, and that 2 is not bigger than 4. If I made my bird 2, my hedgehog would have to be 3. And that's not greater than 4. If I made my bird worth 1, my hedgehog would have to be 4. And that doesn't work because 4 is not bigger than 4. And I can't make my bird any smaller because it will become 0. So I have found all of the possibilities for this problem. You may want to draw it under the animals like I did, or start to create a list. But each time, check each of the criteria to see if it's still following it, still meets it. So this kind of problem is a substitution problem, and it's a problem that you'll start doing in year 7 or 8, but actually we can introduce the concept very early on. Now in our picture it tells us that 2 monkeys and a lion equal 35. Now the first question says if the monkey was worth 10, what would the lion be worth? So this is a really good one to do using manipulatives and counters. So on the screen I have got 2 lots of 10 to represent each monkey, and I need to make all of my counters add up to 35. So if you know you've already got 20, you can simply keep adding till you get to 35. So 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So I've got 35 counters, and I now simply need to count how many counters are in the space where my lion should be. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I've solved my first problem. In my second statement, it says if the lion is worth 10, what would the monkeys be worth? So in my lion pile, I at the moment have 15 counters, so I need to get rid of 5 of them. 1, 2, 3, 4, 5. So I have 10 counters in my lion pile, and I need to add these counters to my monkeys, but I need to do it evenly, because I want everything to still add up to 35. So I'm keeping my initial 35 counters, but I'm taking 5 away from the lion and I'm giving them to the monkeys. Now I have 1 here and I want to share it between the 2 monkeys. So what will that 1 be if I share it between 2? The 1 will become a half. So I'm going to swap that for a red one. I'm going to swap the blues for green. So if I now check each side, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and half. And the other side, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and a half. So if the lion was worth 10, each monkey would be worth 12 and a half. In this problem, you're using the information at the top and you are changing the value of each animal according to the next statements. So, 2 lions, 2 monkeys and a lion add to 35. If the monkey was worth 10, what would the lion be? So I could write 10 on my monkeys. And I know that 2 lots of 10 is equal to 20. And I know that 20 plus my lion equals 35. So using my inverse, I could subtract 20 from 35 to get 15. So if the monkey was worth 10, the lion would be worth 15. Let's have a look at the next problem. This time it says if the lion was worth 10. So this time I would label my lion as 10. And I know that the 2 monkeys plus 10 makes 35. So if I use the inverse and subtract 10 from my 35, I get 25. I know that both monkeys together will add to 25, but there are 2 of them. So I now need to halve my 25, either mentally or I might use bus stop. So if you share 25, you will get 12 and a half. So each monkey is worth 12 and a half. With this question, we have shapes instead of animals, but it's the same concept. We're saying that 3 circles and a triangle add up to 35 when we go horizontally. So that top row going across, 1 triangle and 3 circles add up to 35. A circle will always be worth the same. So for example, if I was to give it a guess and say my circles are worth 10. I could make my 3 piles of 10 first. I've got 35 counters here, so I'm just going to separate them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 1 pile of 10. So if 1 circle was worth 10, then they all have to be worth 10. So that's my second circle. 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I've got one too many. So if one circle was worth 10, all 3 circles have to be worth 10. And then I have 5 left over, so it means my triangle is worth 5. So we would now test it coming down. So if a triangle was worth 5, this is saying 2 triangles in a circle is also worth 35. So there's my 5 for my first triangle. There's my 5 for my second triangle. And then it's saying that my circle, which I have already decided is worth 10, is here. Let's move all these out the way. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That doesn't work because the 2 triangles add up to 10, and then with my 10 circles, 10 for circle, it only adds up to 20, so that's not right. So we need to adjust the amounts for each one. Okay, so with this problem, you've got a couple of things you can do. You can use trial and improvement to just give your symbols a number and then just keep testing it out and adjusting, or you might be able to use the clues that are on the screen. So I'm going to use trial and error first of all with you. So for example, I might decide that each circle is worth 9. 3 9s make 27. That means that my triangle has to be worth 8. I can then label like this, and I would simply check. 8 plus 8 is 16, plus 9 is 25, so that doesn't work. And then I would readjust. So I might decide to make my circle bigger by just 1. If 3 circles were 10, that would equal 30, which would mean my triangle would have to equal 5. If I then carry on down here, I can see 5 and 5 and 10 is 20. So my answer has got smaller. It's got further away from 35 when I made my circle bigger. So that tells me that I need to make my circle smaller. So I might go to 8 next. If 3 circles are worth 8, that's 24. That means my triangle has to be worth 11. And if I fill that out like that, 11 and 22 and 8 make 30. I'm getting closer to my answer, but I'm not there yet. But I'll let you have a go at continuing that on. So pause the video if you think you're ready to have a go at that now, or stay tuned and I will go over a different method. So you can use the clues that you've already got to find out some more information. So for example, I know that both the row and the column have the same value. So what I would be looking at is what is different in each row. So for example, these two are the same. This is the same for both because it's being added to that row and to that column. But this and these are different. I have one triangle here and I have 2 circles here. So that tells me that one triangle is equal to 2 circles, which means that one triangle is double a circle, or one circle is half of a triangle. So if I know that my triangle is double my circle, I can use that to help me out. So for example, for this triangle, I'm going to replace it with 2 circles because it's worth the same. And for this triangle, I'm going to replace it with 2 circles because it's worth the same. And now I can see that in my row and my column, I actually have 5 circles, which is going to make it a lot easier to find out what each circle is worth because they both add up to 35. So I simply need to do 35 divided by 5, which is equal to 7. And that's going to tell me the value of my circles. Now I know that my triangles are worth double, so that must mean that my triangles are worth 14. So now let's check it. 3 7s are 21, plus 14 is 35, so that works. And coming down, 2 14s are 28, plus 7 is 35, so that works. So you can see with the algebraic problems that you can use trial and improvement, absolutely nothing wrong with that. Be systematic. Sometimes getting the wrong answer leads you to the right answer, as long as you're figuring out that when you adjust the numbers, does that take you further away? Does it take you closer to the answer? It's all that learning journey which is the important part. Or you can try and figure out if there are any clues that you can be using. There are loads and loads of other activities in the ebook, so give them all a go. There's all different types, ones with shapes, ones with animals, ones where you're substituting, ones where you're listing all the possibilities. Try and be as systematic as you can. The more you engage with these kind of problems, the better you'll become at visualising the answers and the solutions to them.